Alrighty, subtraction. Same thing. I'm not going to draw my segments out here. What could I say here for subtraction? A minus. Now A minus. What could I subtract from A? Should we have the segments then?
Yeah.
And those are congruent to each other. A and B are equal. C and D are equal. So which pairs could I subtract that are equal? Oh, now we have hands. Yes, Matt?
A minus C.
Yep. A. If I take segment A, subtract angle segment D from it, that's the same as subtracting what segments?
B minus C.
B minus C. Was that the only thing Matt could have gave me? Nope. What else?
A minus C.
A minus C is the same as doing
B minus D.
B minus D, and that is subtraction. Just like addition. How many pairs of equal quantities do I need? Two. Two. Still need two. Right? Just like addition, except now I'm getting smaller. All right, let's check out subtraction. What's a subtraction proof look like? Example 1. Angle DAC and ECA are equal. What type of angles are they, by the way? Straight angles, right? Everyone see those? 180 degrees, they're straight angles. And 1's congruent to 2. Mark them. Mark them. 1's congruent to 2. I make it too easy on you guys. I write the givens in for you. Make it too easy on you. And y's 3 congruent to 4 now. Okay. Breath. Take a breath. DAC, that's a straight angle, 180 degrees, right? And I'm going to angle 3. Are my angles getting smaller or bigger as I go from the given angle to the prove angle? I'm going from 180 degrees to angle 3. Is it getting smaller or bigger? Smaller. Everyone agree it's getting smaller. So the only way I can get smaller is if I do what? Subtract from the given angle. We all see that. Why this is not addition now. I'm getting smaller. I'm going from 180 degrees DAC to angle 1, which is smaller than 180. So the only way I can do that is to subtract. How many pairs do you need to subtract? 2. How many did I give you? 2. So can we subtract right away in step 2? Okay, let's see. Let's see. Angle DAC minus which angle? 1 is equal to, what's the other straight angle? ECA minus angle 2. What allows you to write that? How do I know they're equal? Subtraction. All right. Let's see if I don't know if this will work as well as I want. Probably not. Okay, ready? Take DAC right now. Watch. Cover up angle 1. Subtract it. What's left? Take DAC. Subtract angle 1 from it. What do I have? What do I end up with? Angle. Everyone see how I just subtracted that with the little black box here? Angle 3. And what happens if you take ECA and subtract angle 2 from it? What are you left with? Angle 4. And what gave me the right to plug in 3 and 4 instead? Substitution. That's always going to happen, that I'm going to have substitution right after addition and subtraction. What do you think here? Questions? on why it's my big thing, why it's subtraction versus addition. Because I'm going to sneak some addition ones into tonight's homework too. So we okay on why it's subtraction versus addition, how you're getting smaller now. Okay. What's the deal here? DF and BE are congruent. Okay. How you want to mark that's up to you. I usually just try to DF, BE, and I'll put my hash marks on those. It's up to you how you want to symbolize it. And I got to get DE and BF equal. All right, ready? Are you getting bigger or smaller? Givens to prove. Givens to prove. Is the segment's getting bigger or smaller?
Small.
Can we all agree it's smaller? So I got to subtract something. Ooh, I can't subtract though. Why not?
You only have one pair.
Yeah, I only have one pair. I need another pair to subtract from them. So that's on you guys. Where's that other pair I'm going to subtract from both? Grace?
Yeah.
Everyone agrees I'm going to subtract EF from both to get DE and BF?
Yeah.
Everyone sees that. All right, so what should statement 2 now read?
EF is congruent to EF.
EF congruent to itself. What makes that true?
Reflexive.
Are we maybe starting to pick these proofs up slightly? Reflexive. Next,
EF.
do you have 2 pairs now to subtract?
Yeah.
Okay, now show me you're just going to subtract them now. All right, I got to start. Now here's where I got to take hands off and start calling on people. Where's my sheet of numbers? I don't have them. And we don't even have a 19. Three spot. Good talk. Hi, Niara.
I'm still figuring it out.
Well, I'm just looking, what should I write in the statements now? You know it's subtraction, right?
Yeah.
So now we got 2 pairs of equal quantities. Now tell me what we're going to subtract.
DF.
DF is going to be subtracted. DF minus
BE.
DF, and what they're congruent to each other,
Oh, then
right?
EF.
EF, right? I want to subtract EF from it, and that'll be the same as subtracting what on the other end? BE minus EF. Good. What gave you the right to do that?
Subtraction.
Yep. And here we go with 4. Can you replace now? Replace. 1, 7. Hi, Maddie. DF minus EF.
Is DE.
DE. BE minus EF.
EF.
BF.
And that's substitution.
Yep. Subtraction questions. All right, let's add it up. Okay, 1 down, 1 to go. Okay, now we're going to take a little turn here and get away from addition and subtraction. Now what we're going to talk about is taking halves, ready? Halves of 2 equal quantities. Okay, halves of 2 equal quantities. Okay, for instance, if I tell you, please don't copy this down here. Line segment AB, line segment CD are congruent. I take half of AB. I'll call it AM. I take half of CD. I'll call it CN. What do you know about AM and CN? Don't they have to be equal? If the originals were equal and I took half of them, aren't those halves equal too?
Yeah.
Everyone agrees with that, right? Okay, if you don't understand that, let me make it even easier. Let's say that's 10 units and that's 10 units. This will be 5 and 5. Okay, the halves are going to be equal. That is what this next theorem says. Halves of equal quantities are equal. But, ready? Checklist right before we get into our first proof. If you want to use this, you got to have equal quantities that you're going to take half of. Okay? What you're taking half of need to be equal first, whether you tell me or I give it to you. And also, somewhere in your statement, you need to show me you're going to take half of those equal quantities. Okay? So what you're going to take half of need to be equal, and you got to tell me you're taking half of it. So those are the two things I need before I'm allowed to write down this reason right now. Halves of equal quantities are equal. Let me challenge you even more. Keywords. Vocabulary words you may see in the given that says, ding, 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 I'm going to be taking half of something here. I'm looking for two specifically. Two vocabulary words we've talked about in the past, Unit 1, that signify, something's being taken half of here. Anybody? I'm taking half of something. Come on, you know at least one of the two. Yes. Bisector. Good. If I see the word bisector, something's being cut in half. So we'll start there. Bisector. And I'm looking for one more. Grace? Midpoint. You see those two in a proof? You see those two? Oh, we're doing halves of equal quantities probably. All right, well, because we're about to take half of something. All right, ready for a basic one right now. A, B, D, C are equal. Okay, A, B, and D, C are equal. What am I doing to A, B? I'm taking half of it. Everyone agree? And what am I calling it? AF. All right, everyone see what I don't need a visual for this. What am I doing to DC? Taking half of it and calling it. Okay, what did I know about A, B, and DC originally? They're equal. So what am I doing? I'm taking halves of equal quantities. All right, everyone sees I'm doing that and calling them AF and EC. So what should I know about AF and EC then? They're congruent, equal as well. You're taking half of AB and DC, which are already equal. So their halves, AF and EC, must be equal. And that's our new theorem. Halves of equal quantities are equal. But again, there's certain things you need in the proof before you're allowed to say that. You need to say you have congruent quantities, check, and you're taking half of them. So basically, I gave you everything you needed. But next proof, you're going to have to write it down, though, yourself. Anything you want to ask before we got one more? One more? Yeah? Okay. God, I made it too easy. It's already written in there for you. You kids. Okay. Whoa, right away, what do we see in the givens? Ding, 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 ding. Something's being cut in half, right? What's being cut in half? CA bisects. So angle DCB is being cut in half, and so is angle DAB. And what do I know about those two angles? Keep reading the givens. Mark it on your diagram. Those angles are congruent. DCB, whole angle, congruent to DAB, whole angle. Okay, let's review again. How do I know the angles are being cut in half? I see the word bisector. What I'm cutting, are those angles equal? Those angles I'm about to cut in half, are they equal?
Yes.
Okay, that was number one, what I need. Number two is, show me you're taking half of them. Remember what I gave you here? Show me you're taking half. Now you have to come up with that because I didn't give that to you. Okay? I have what I'm going to take, what I'm going to cut in half are equal. I got that already. Now you got to show me you're cutting them in half. So ready? Half, what's one angle we're cutting in half? So half of angle DCB is equal to, now, everyone look at your diagram right now because I'm in a predicament and I need you to help me. Everyone look at DCB. I'm cutting it in half. So I can say this is equal to DCA, or I could say it's equal to angle S, right? Because everyone see, that's both sides of the angle. Which one do I only care about, though, in this proof? Darn right, the one in the proof statement. So I'm going to say half of DCB is equal to angle S. I don't need it to be equal to angle. It's true, but I don't need it that it's equal to angle DCA. Next up, what's the other angle I'm taking half of? DAB. So half, in the same statement, half of DAB is equal to, now you could go angle DAC or angle R, but which one do I care about? Which one do I care about? Which one do I care about? What are you guys, pirates? All right, moving on. Scott set them up all the time. Everyone get that one, pirates? We're good because you kept saying R. Yep. Good, good. Yep. Perfect. Where do pirates like to eat?
Vitamin D.
Arby's. Come on, get your acts together. Favorite vacation spot? Argentina. Come on, you're better than that. Honors kids.
You can say Aruba too.
That don't. No, it's Aruba.
Yes, you can.
No, it's Aruba. That's it. Argentina works perfectly. Come on, get your acts together, honors kids. All right. Movie. Pirates favorite movie? Ooh, tough one. Anything rated R. He's got a million of them. A million of them. Come on. All right, now why? I'm taking half. This is not halves of equal quantities, though. What told me in the givens you could take half of those? What told me in the givens that DCB and DAB were going to be cut in half, Matt?
The bisect.
Definition of a
Bisect.
bisector, yeah. This is why I kept you guys writing down all that half stuff the first day of this unit. Checklist, ready? Checklist. Let me go back to my checklist. Do I have equal congruent quantities? I gave you that, right? That's these two angles right here, DCB and DAB. Do you have a statement saying you're taking half of them? Did we write down a statement that we're taking half of them? Yes, we did. Right here, half of DCB, half of DAB. What should we know about angle S and angle R then? They're congruent now because I'm taking half of DCB and DAB, which are equal. So their halves are congruent. And this is halves of equal quantities are equal.
So would it be substitution?
No, nope. I can't. I don't have any repetition. Okay, I don't have it. Ready? That's DAB, that's DCB. I can't take R and plug it in here because those aren't equal.
Okay.
See what I mean?
Yeah.
So that's why we're using halves of equal quantities. Yep, no substitution here. Got to have equal quantities. Got to tell me you're taking half of them before you're allowed to use halves of equal quantities. Okay, questions? Let me take a quick peek at the homework tonight. I do think I threw in a little addition there at you just to keep you on your toes, and I did. Okay, I did. I threw an addition one in there somewhere to keep you on your toes, so just don't assume it's subtraction, subtraction, subtraction. And if you see halves, bisector, midpoint, we're thinking halves of equal quantities are equal. Okay, you guys got 10 minutes here to go ahead and start this.